In this video, we're going to go over an actual example of a sort of a real-life application of quadratics. All right, so this is going to involve standard form factoring, all that jazz, and we're going to use all that information or all the knowledge that we know to help answer some of the questions. So let's read the problem first, and then I'll give you the questions that we need to solve. So Jose hits golf balls off the edge of a vertical cliff into a pond. The trajectory of his ball can be modeled by h equals negative 5d squared plus 20d plus 60. So we know right away that this is going to be a parabola because we can see the second degree. We see d squared. So we know right away that this is a parabola. Where h is the height of the ball to the sea level, so in other words to the pond, and d is the horizontal distance to the cliff. So the first thing we should do, like we're going to look at some questions in the next slide, but the first thing that we should do is draw a quick sketch of what this sort of looks like. All right. So here it says Jose hits golf balls off the edge of a vertical cliff into a pond. So in other words, there's some cliff right here. Okay. And Jose is in the top of that cliff. He's like right there. That's where Jose is. Okay. And basically he's hitting some golf balls from there, and it's shooting up and then going down into some pond. And let me just scroll down here. So let me just do that. So it's into some pond, and here let me just draw some blue water. So here's like some pond over here. All right. So this is a sketch of what's actually happening, and what you can do is the first thing you should do is maybe draw sort of a set of axes. So we can observe right away that here's one axis, and then here is another set of axes. So let me go back here. Oops, no, I don't want blue, I want white. Go back here. So here's that, and here's that. So let's look at the variables that we've been given. We've been told that h is the height of the ball to the sea level. So here's the sea level. So the height of the ball is right here. So this is h, right? And also we know that because we can see that this is sort of the y-axis, so that's h. D is the horizontal distance to the cliff. So this yellow thing right here is the cliff. So the horizontal distance to the cliff must be this. So this is d. So if I'm here, let's say here, this is sort of my distance horizontally away from the cliff. So if I'm right here, this is the horizontal distance to the cliff. Okay, I'm just going to remove those because they're a little bit distracting. So anyways, so h is the height of the ball, as we can see, and d is the horizontal distance of the ball to the cliff. All right, so this is the diagram, and now in the next slides, let's go over some questions. So here, the first question says, find the height of the cliff. So in other words, we are expected to find this height over here. What is that height? So our equation, if you recall, is h is equal to negative 5t squared. What is it again? I wrote it somewhere here. Okay, it's 5t squared plus 20d plus 20d plus 60. Okay, so find the height of the cliff. So if we want to find the height of the cliff, that is where what d stands for the distance to the cliff. So the distance to the cliff right here, this is basically going to help us find the height, is 0. So the distance to the cliff is 0. So when d is 0, that will tell us what the height of the ball is. And the height of the ball is really, at this point, is basically the height of the cliff. So h, which stands for the height of the cliff, is going to, h, which is basically the height of the ball. The height of the ball is the same as the height of the cliff when d is equal to 0. So, this is supposed to be d, not t. I don't know why I wrote t there. So this is going to be negative 5, 0 squared, plus 20 times 0 plus 60. So it's equal to, this is going to be 0 plus 0 plus 60, which is equal to 60. Let's assume that everything is meters. I should have put that in meters. But anyways, it doesn't really matter. Let's assume it's 60 meters. So another way you could have sort of determined this without even thinking is that you can see that right away it's at the y-intercept. And when you have a y-intercept, that means the x is 0. So notice d is 0. So you could have figured it out two ways, logically, or you could have done it this way. So the height of the cliff is 60 meters in this case. Let's assume everything here is in meters. Let's go to the next problem. Find the distance from the cliff where the ball sinks into the pond. So in other words, the ball sinks into the pond right here. So we got to find this distance we have to find this distance where the ball sinks into the pond. So because the distance from the cliff, so in other words, d. So if you think about it and look at this sort of diagram, if I were to say extend this parabola backwards, right? What do you observe right here? What is this point and what is that point? These 2 points are basically the x-intercepts. So we don't want this x-intercept, we want the point where the ball hits into the pond. So let's figure out what that x-intercept is. So we have, actually red is fine. Let me just use red. So we have, this is negative 5t squared plus 20d. Oh, why did I put t again? Let me just change that. So negative 5d squared, d squared, plus 20d plus 60. So we want to find the x-intercept, and here, if you observe, we're given the standard form. So how do we go from standard form to finding the x-intercepts? Well, we can use the factored form. So let's figure out what the factored form is. So if we want to find the x-intercept, so I know one thing you can do here is use the man method. So you can do m, and it'll be negative 5 times 60. But one thing you can do if you think about it is you can factor right away and make your man method a little bit easier. So what I can do is I can actually factor out the negative 5. So negative 5, and what's going to be left is d squared minus 4d, because negative 5 times negative 4 is positive 20, and then it's going to be minus 12. Okay? Because negative 5 times negative 12 is 60. So what we can do is we can factor this. We don't have to worry about the negative 5. It actually makes our factoring a little bit easier. So if we use the man method, m is equal to the first term here, which is 1, times negative 12, which is negative 12. A is equal to the middle term, which is negative 4. And n is equal to, so we need to find 2 numbers that multiply to negative 12 and add up to negative 4. So I can think of negative 6 and 2. So what that does is, I'm going to write this here, so it's going to be negative 5. Leave that negative 5 out there because we're factoring this part. So it's going to be d squared, and this middle term will split. So it'll split into negative 6d plus 2d minus 12. And then it's going to be negative 5, so we group these two and group those two. So it's going to be d minus 6 plus 2d minus 6. Close the brackets there. I'm just going to scroll down a little bit. So it's going to be negative 5. So we observe that these two are the same. Let me just use yellow. We observe that these two are the same. So it's going to be d minus 6. And what's left is d plus 2. So d plus 2. All right? So, and that's equal to h. So if we want to find the x-intercepts, remember, that's where the height of the ball is 0 compared to the sea level. So h, if you observe right here, is 0. H is 0 right here, and we want to find what d is. So we need to set h to 0. So this is basically like finding the x-intercept, or the x-intercept. Remember, when you want to find the x-intercept, you need to set y to 0. And in this case, our y is h. So what I'm going to do is I'm going to set y to 0. I'm going to use yellow just to be a little bit clear. So it's negative 5 d minus 6 and d plus 2. And what we observe over here, we can divide by negative 5. So basically 0 is just going to equal to each of these. So d minus 6 is equal to 0. So d is equal to 6. So that's one x-intercept. And then d plus 2 is equal to 0, and d is equal to negative 2. Okay? So which one do we want? Do we want d equals 6 or d equals negative 2? Well, if you observe over here, here would be negative 2, and here would be 6. We are looking for where the ball hits into the pond. So obviously 6 works. We're not going backwards. We're not hitting the ball backwards. So this does not apply. So if we look over here, this is not what we want. We want d equals 6. So our answer is the horizontal distance, horizontal distance of 6 meters to the cliff. All right, so the ball will land 6 meters from the cliff, and 6 meters from the cliff, basically, into the pond. Let's do C. So in C, it says find the maximum height of the ball. So if we want to find the maximum height, right, find the maximum height of the ball, so in other words, it's somewhere over here. And if you observe, if it's a parabola, where can we always get the maximum height, or the minimum height, depending on the parabola? And that is going to be where the vertex is. So that's going to be where the vertex is. So basically, we need to find where that vertex is. And from the previous problem, if we go back to B, I observed that I could factor it as h is equal to negative 5 d minus 6 d plus 2. So this factored form is going to help me figure out what that maximum height is. So h is equal to negative 5 d minus 6 and then d plus 2. And I drew it this way, so it's negative 2 over here and there's 6 over here. So our vertex is going to be halfway through, because remember, the axis of symmetry is halfway between the two x-intercepts. So let's find the axis of symmetry. So the axis of symmetry, I'm just going to write sim for symmetry. And remember, our equation was x equals p plus q divided by 2. And what we determined was, from the previous equation, was it was negative 2 and 6. So it's negative 2 plus 6 divided by 2. So that's equal to, or that's equal to 4 over 2, which is 2. So we know that the x value, or the d value in this case, is going to be 2. So we're going to have our maximum height when we have a horizontal distance of 2 away from the cliff. But the question said find the maximum height of the ball. So we're not interested in the distance from the cliff, we're interested in the height of the ball. So we want to know how high it goes. So all we have to do is, instead of x, I can just say that d equals 2. So what I need to do now is take this value and plug it in here to figure out what the height will be. So h is equal to negative 5 d plus 6 d, oh sorry, it's not d plus 6, it's d minus 6, d minus 6. So it's d minus 6, d plus 2. And what we're going to do is we're going to plug in this d equals 2 right into here. In other words, our axis of symmetry, we're going to plug in the value of our axis of symmetry right into this equation. So it's going to be negative 5, 2 minus 6, and it's going to be 2 plus 2. And that's going to be negative 5. 2 minus 6 is negative 4, and 2 plus 2 is 4. And this is going to be 20 times 4, so it's going to be 80. So the answer is it reaches the maximum height of 80 meters. So the coordinate, so basically here is going to be, it's going to be 2, 80, which means that at a horizontal distance of 2 meters from the cliff, we get a maximum height of 80 meters, which is the height of the ball. So that's how you find the maximum height of the ball, which, let me just go back here, is 80 meters. So that's our answer. Okay, D. Find the horizontal distance from the cliff where the ball reaches the same height of the cliff after Jose hits the ball. All right, so what does that mean? That just sounds like a mouthful. So let's read that again. Find the horizontal distance from the cliff. So in other words, we got to find something to do with D, because D stands for horizontal distance from the cliff, where the ball reaches the same height of the cliff after Jose hits the ball. Okay, so here's the height of the cliff. This right here is the height of the cliff. So where we want to find the horizontal distance, where the ball is going up and up and up and up, and then reaches the same height of the cliff. So in other words, it's going to go up and then reach right there, right? So we want to find what is this distance right here, where the ball reaches the same height of the cliff again after Jose hits the ball. So we need to find this distance. So using all the information that we got from the previous parts of the question, we know that our axis of symmetry is x, or d equals 2. We know it's d equals 2. So if it's going to be d equals 2, and we know that this is 0, right? So in other words, this distance from the axis of symmetry is also 2. So the distance on the other side, if it's symmetric, remember we want to find the symmetric point on the other side, must also be 2. So what is the value of d over here? Well, d has to equal to 4. So just using logic, basically, we know that our axis of symmetry is d equals 2. We know the distance from where it starts is 2. So on the other side, it must be the equivalent distance from the axis of symmetry. So the total distance from here to here is 2 plus 2, which is equal to 4. So d is equal to this 2 plus that 2, which is equal to 4 meters. So the horizontal distance where the ball reaches the same height of the cliff after Jose hits the ball is 4 meters, and we are done with this question. All right, so that's it for this series of videos. I'll see you in the next set of videos. Bye.